what happens also during these quantum fluctuations? Well, you know what happens with your genetic code. Sometimes there are some mutations, your children come not exactly like you, and well, whatever, maybe smarter, maybe not, but things are changing. So here in the universe, you have all information about its previous, subsequent existence, somewhere encoded in the rules, in the laws of physics. You know that water is liquid. You know that electron has mass 2,000 times smaller than the mass of the proton. You do not know exactly why, but you consider this is your universe, and that's all. Laws of physics are written here, okay? Actually, where they're written is a very good question, because suppose universe, well, like in old normal picture, the universe was born at the moment t equal to 0. There was no universe before, right? Okay? So then the universe starts behaving like something obeying laws of physics. Okay? Now, law of physics is something which you write on the blackboard, talk about with your friends, etc. But there was no blackboards there. So where this law of I'm not kidding, the law is something which has some information value, okay? Something which has some words in it, equations, but there was no way to write your equations on non-existing blackboards because everything was created with the universe. So you ask, what was first, the law or the universe? Either the universe was created without any law, then what do you expect? Okay, yeah, chaos. Or if the law existed before the universe, then the way it was written. So you have all of this strange stuff, but now at least what we know, that if the universe starts inflating with a given law, and what I mean by a given law, like you have this scalar field, and the scalar field may have this normal one minimum, which I've shown you, okay, where you're falling, but it may have many different places to stop on the way. When it stops there, you will have the same theory, basically. It's just scalar field takes different value. When it takes different value, particles have different masses. And electron may be much heavier than it is now in our part of the universe. When the universe is multicolored, multicolored means that the laws of physics may be different in different parts. Maybe there is one fundamental law of physics, like, well, string theory, for example, but it may have different realizations, just like water can be liquid, can be solid, different types of this same water. So it's not something that we are breaking our custom, saying that law of physics does not tell you anything, but we are saying that even if you have one unique law of physics, which is not a given, but if you have this one law of physics, it can be realized differently. And what we know also that these quantum fluctuations can bring you from one place with one law of physics to another place with another realization of this law of physics from liquid to solid and back. So then, how does it happen? This is a result of computer simulations, how you start with a red universe, and then everything was fluctuating, and then in the end of that, you have a huge universe, you have all of these peaks, and this peak is kind of beginning of the new expansion. So you're creating multicolored multiverse, and some of these countries are expanding exponentially and become much larger than the previously existing countries. And the colors there are not yet fixed. You are jumping from one minimum to another minimum, from one value of the scale field to another. But then in the end, you roll down to these places here. So it's red, it's blue. Red is exponentially large. Blue is exponentially large. When you are in red and you want to travel to blue, it's exponentially far away from you. So it's not easy to travel from one country to another, essentially from one universe to another. Now, if, however, you have lots of money, build a big rocket, and this distance does not matter much for you because your time for you is relativistically shrunk. So you travel, and for all other observers, it takes infinite amount of time to travel. But if you are traveling approaching speed of light, then eventually you reach the boundary between red and blue. Hey, no policeman. Oh, but there is a domain wall separating these two parts. So if you are young and stupid and energetic, you jump through the main wall, and then you die there because particles of your type cannot live in this blue universe. So it's very safe arrangement. So, okay. Well, one way or another, let's continue a little bit further. Where this genetic code of everything is, well, written. And here, string theory comes to help us, something which we did not know before. And this, essentially, the main developments happened about 10 years ago. So what happens is the following. String theory is supposed to be a king or queen of all theories, which is the theory of everything. It has one strange property. It's easier to formulate it in 10-dimensional space. But then we live in 4-dimensional space, 3 dimensions for space and 1 for time, 4. So then you have 6 extra. And these 6 extra, we do not see them. We cannot move in these directions, supposedly, because they are squeezed into something very, very small. So you cannot put your finger there. You cannot send a particle there. You cannot talk to your friends traveling in this direction. And these directions are squeezed like that. And they can be squeezed in many different ways. How many ways and how they squeeze? So the fact that it is possible, it's all consistent. For many years, we did not even know that it is a consistent picture. We did not know what keeps these 6 dimensions from expanding. And then there were some mechanisms were proposed, one of them at Stanford University, and I participated there like cosmology consultant. And then people found that when you have one mechanism how to stabilize it, there are many. And how many mechanisms? Well, because you can squeeze it this way and that way and many other ways, you have combinatorial greatness of the number. In fact, the first time it was suggested that you may have this combinatorial hugeness of the result, which is given by maybe 10 to the 500. The first time it was suggested by Andrei Sakharov. I was, you know, this famous Russian dissident who helped to build thermonuclear weapons and then tried to, well, stop this nuclear race. And so he was in Gorky in Russia, and I was from time to time, as well as some of my colleagues were traveling to him, which was pretty depressing. One thing which kept him, well, there alive and interested in what is going on, all of his, well, place was covered by preprints sent by other people. And we discussed with him this possibility of compactification and everything else. And then he said, but actually there are many compactifications. There may be something good in it, because if there are many compactifications, then in some of these compactifications, you will have universe just the one like we see right now. In particular, there is some magic thing about our universe. Energy density in our universe, energy density of nothing, of empty space, is almost exactly 0 with incredible accuracy, but not 0. If it were 0, then we say, okay, there is some symmetry which tells it that it must be 0, but it is not 0, and that was found in '98 by exactly these experiments with supernova, which I just described you. So this extra thing is dark energy or something like that. So the best interpretation of dark energy is just the energy of vacuum, which is non-zero. But why it is just like that? Okay, because there are so many different ways of compactifying space. There is some where energy density is huge, but then you cannot live there because galaxies are torn apart by this rapid expansion of the universe. It's like having inflation right now in this room. Then you will not listen my next word because your tables will be exponentially far away. Okay? Then there is another possibility that it is negative energy of vacuum. That's also a possibility. But the universe of our type with negative energy would momentarily collapse. And then, so there would be no discussion at all, and you would be even born. So there is just a little bit of interval of energy where everything is fine. We're not dying due to collapse, and we're not torn apart. And then this is something which anthropic principle uses. They say, we cannot live here. Yeah, we just cannot. We cannot live there. But of course, if we do not have any opportunity, if you do not have these different universes where energy density is large, small, whatever, if you cannot try, then it's all metaphysics. Because the universe is given to you, and whatever is there, this vacuum energy, you are taking it because you don't have any choice. But if you have multiverse, if you have this many compactifications, then in one part of the universe, you may have one vacuum energy, one value of vacuum energy, another, and then you live in a part where you can live. So then it is no longer metaphysics. It's just like dolphins live in water, you live on the dry land, and that explains your property correlates with dry land. That's all. So there's nothing metaphysical in it.